The range of the wavelength of the visible light is around 380 to 700 nanometers, which is given over here. Nano means it's the range of 10 to the power of minus 9 meters. Ultraviolet light is a type of electromagnetic radiation which makes black light posters glow. It's responsible for summer tans or sunburns as such. Gamma rays, as you can see in a picture, it can be helpful to diagnose the tumor in your brain. So a gamma ray is a packet of electromagnetic energy. Hello everyone, I'm Brinda, Faculty of Physics, welcoming you all to Chapter 8 and the Session 1 of Electromagnetic Waves. This is a very easiest chapter wherein you have to know the applications of each and every electromagnetic waves, whatever we study here. So now, in order to know this, what is meant by electromagnetic waves, if you have seen, so they are the waves of the electromagnetic field which will propagate through space, which carries electromagnetic radiant energy. Electromagnetic, both the unification, that is the unification of electric field as well as magnetic field occurs over here, and the propagation is perpendicular to each other. The direction of the propagation will be in the same direction. The magnetic field lines are moving this way, your electric field lines will have your propagation perpendicularly to this. So that is how the perpendicular movement of the magnetic field with respect to the electric field is called as your electromagnetic waves, which are radiating, which gives you a radiant energy. So let us see which are those waves. There are 7 types of electromagnetic waves which you'll have to know. That is, one is radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. So as you can see here, there's a blue lines as well as the red lines. That is a sine wave. The waves are moving there. So when you can see this, you can differentiate this red line as magnetic field and blue line as electric field. The propagation direction is towards x-axis or whichever axis you consider. And then the wavelength, as you all have studied in your first PUC or the class 11 about the wavelength, this is how exactly it is. One wave to a crest of one wave or trough of one wave is called as the wavelength, which is mentioned with respect to a lambda. Next, we have what is meant by a radio waves. So here, radio waves are the waves which has the longest wavelength in the electromagnetic spectrum, which you usually see in your radio waves and all those stuff, wherein you will, for televisions or radio frequency, you will modulate it. Such kind of a wave are called as radio waves. It can be through sky or through underground. All these concepts you can study in this radio waves concept. So next we are going to for microwaves. So microwave, you can see in microwave oven, like burger is getting heated, that is microwave due to the help of a microwave radiation, where magnetron tube, that is the source of radiation, comes from the right hand side or the top of the microwave, which is used in order to heat the cooking materials. So not only for this purpose, it is also used in case of your cosmic microwave, that is background radiation is a natural source of microwave is what we have exactly. So microwave radiations also we feel it, that is due to the cosmic radiation, natural source it is. Next is lower frequency radio waves can follow the contours of the earth and bounce off the layers into the atmosphere. And important property of the microwave radiation is that it's absorbed by moisture. Okay, so microwave radiation is the one which can be absorbed by the moisture of a food content, because of which it gets cooked well. And next is a phenomenon called as rain fade occurs at the high end of the microwave band. That is one more concept. And it is also used in radar, students. Microwave can also be used in case of radars. Communication, including analog as well as digital voice and data and the video transmission concept. And a radar which uses a microwave can also detect the speed of the ball in case of your cricket match or tennis ball or all those concepts. Okay, so there also your microwaves are used in case of the radars. Next, you have your, that is what it is. It is used in a radar or weather tracking also, as well as air traffic control also you can use in case of flight and all those stuff, in case of your aircrafts. And then man-made source of microwave include ovens, maser, circuit, communication transmission towers, as well as radar. This is what you have to know with respect to microwave. These are certain applications which you'll have to remember. Next is infrared rays. Infrared waves are the longer than those of the visible light, but it is shorter than that of the radio wave, because it is accordingly, once it is a radio wave, then it is a microwave, then it is infrared rays, whatever we study. So infrared rays, it is always invisible to human eye. So you can give an example of a television remote. Once you start clicking on it, there's an infrared radiation which moves, which passes, but you can't see that. There is a connection between your TV as well as your remote. Yes. So that is what it says, invisible to a human eye. Longer infrared can be sensed as heat. Okay. Next is infrared ray can be focused, it can be reflected, it can be polarized. Reflection, you know, as it pictures, you get the same mirror image of it. And polarized means the polarization concept. One which arrives in a different direction, n number of direction, it gets polarized in one single direction. Okay, so that is about the polarized concept, and commonly separated into near, mid and far infrared. It has got the three separations: near infrared, far infrared as well as mid infrared. Next is you have, this is what infrared thermal imaging actually captures with respect to the temperature of a object. Okay. Next you have uses of the infrared rays. So it is used in wired and wireless operation also, and remote control use near infrared lights, and it sends focus signals to home entertainment devices, as I have told you with respect to the television. It is used in a fiber optic cables to transmit data. The complete chapter is all about the applications of your electromagnetic waves. So it's very easy for you to understand what are the uses and applications of it, which comes usually in your comprehensive type of questions, for which you will have to just understand how exactly these radiations work and for which purpose these radiations are used. Next is visible light. As you can see a beautiful pictures. So it is visible to you. Similarly, it's a segment of the electromagnetic spectrum. What is the segment? This visible light is a segment of electromagnetic spectrum the human eye can view. That is, we can view these easily. So the range of the wavelength of the visible light is around 380 to 700 nanometers, which is given over here. Nano means it's the range of 10 to the power of -9 meters. Okay, so this is all about your visible light concept. More of the applications or the more of the uses turns out to be, visible light is the range of electromagnetic waves the human eye can see. So anything whichever glows or gives off the light, it makes wave of what we call it as visible light. The sun, the light bulbs, the candles, fire, all things it is automatically think of when it comes to light, right? So obviously, when we think about light, all these concepts only come into our picture. Because of these concepts itself, because of the light itself, we can visualize the outer atmosphere with the help of our eyes. Few of the things which are invisible are a set of radiations that actually we have studied, like microwave, infrared and all. But there is certain applications of it, a strong application than that of visible light maybe. Next, some other source of visible light, it includes television, computer screen, glow sticks as well as firework. So these are all the certain small applications of it. Next we have rainbow colors, that is all 7 colors, which is made up of one single white color. Due to certain changes, optical illusions or the optical changes, we have got a rainbow pattern in case of your white light concept. Next we have, it is used extremely important to a human eye so that we can see it. And aside from the sight, there are important uses of visible light. So let us see. We concentrate visible light to make lasers. So mainly it is used to make lasers, to use everything from the surgery to CD players to laser points, all those. And visible light waves also make our TV, computers and the phone screen also to work. That is what? These are the general applications of the visible light. So is visible light dangerous is the question. So let us just see. Visible light is typically, it is pretty harmless. Okay. So however, but too much of exposure may spoil your retina of the eye. That is, either the image will be formed before retina or after retina, which gives you short-sightedness or the long-sightedness concept. Yes. So instead of regularly having a connection with these harmful rays or something, it's better to avoid these artificial components of visible light and concentrate on your natural one, that is by looking into the nature natural visible light. Okay. So next is ultraviolet rays. So this is also one of the most important component, and you also know that you people keep talking about this UV rays and all those, and you use UV creams and all just because to avoid the ultraviolet radiations to fall on the skin, because these ultraviolet radiations are the radiations which causes suntan concepts. Okay, so ultraviolet light is a type of electromagnetic radiation which makes black light posters glow. It's responsible for summer tans or sunburns as such. Too much of exposure to UV rays damages the living tissues, that is the cells of the skin. And electromagnetic radiation which comes from the sun will always be in the form of different waves, different frequency, different wavelength, out of which this UV light falls in the range in case of your electromagnetic waves, that is between visible light as well as your X-rays. So in order to avoid this fall of UV radiations to damaging the skin, we use the cream that is applied to avoid this UV rays will be in the terms of nano materials. That is, all the creams comes under the nano materials. If you just go on studying each and every bit, are so very interesting. So X-ray. So here we just check out what is a X-ray. X-ray means it's a form of a electromagnetic radiation which is similar to that of a visible light. But introducing an X-ray to a body, it may be harmful. No continuous exposure should happen. That too, especially in case of your pregnant ladies and all. All these people should avoid the involvement of this X-ray to their body, that is to their fetus. Okay, so now X-ray have high energy and it can pass through most objects including the bodies. That is, it's a high energy which is passing. No? So most of the people should avoid all those concepts of high energy which is passing towards the body. So medical X-ray are used to generate, why is it used? To generate images, tissues and the structure which is present inside the body. Okay, regular X-ray is not that good because it's a high energy which is passing to an object. It may be harmful, it may affect the body. So one type of X-ray detectors is photographic film. There are other types of detectors which produces your digital image, and these X-ray image is actually followed up with the help of a process called as your radiographs. So as you can see here, the structure of your human body. If you want to scan any of the internal organs or the internal bone of a human body, then you can just go with this. It can be used in order to check out the tumors or any dental problems or any injuries which has happened with respect to the accidents also. You can check under this. And next is gamma rays. Gamma rays, as you can see in a picture, it can be helpful to diagnose the tumor in your brain. So a gamma ray is a packet of electromagnetic energy. So again, it is in terms of photon. Photon will be having an energy of h nu, which is emitted by a nucleus of some radionuclides. Okay, so here gamma photons are the most energetic photons because E is equal to h nu. Okay, that is the energy of the photon. So now those are the ones which are helpful in case of detection of the tumors. We have come to an end of this chapter. That is, we have discussed all the applications of these electromagnetic waves, which are very easy and the direct ones. Okay, this chapter is mostly involved in terms of your comprehensive type, so for which you have to know the uses as I told before. Let us all meet in our next upcoming session. Until then, have a good day. Thank you.